Yeah, yeah, yeah. It's in this one. Yeah. Okay. Is there any other question? Okay, let me go to today's. We started the other time. We started the hypothesis testing. Okay, and today we're going to continue. So, in the outline, we're going to talk about hypothesis testing for mean, both one and two population. You know, the other time we've been focusing on what? We've been focusing on proportion on Wednesday, but right now want to focus on mean, and I'm also going to tell you, show you possible errors in hypothesis because we could have some errors. So we're going to discuss that. Then we're going to discuss limitations and common misinterpretations. Okay, so let's get started with one sample hypothesis testing for mean. Now take a look at this. If I want to have hypothesis testing for mean, okay, I told you the other time, the non-hypothesis is always going to be equality sign. Alternative could be less than, greater than, or not equal. You're actually going to figure that out from your data. Now, the next is the test statistic. Okay, the next is the test statistic. The test statistic is going to be this. Okay, where the estimator, the hypothesized value, and the standard error, and we're going to have a rejection region. Rejection region, if you take a look at this, the rejection region depends on the alternative. If alternative is greater than, rejection region is going to be Z greater. If the alternative is less than, the rejection region is going to be that. If the alternative is not equal, the rejection region is going to be that. Okay, so you can see different rejection region depending on what you're testing on. And I told you the other time, your non-hypothesis can always be, the non-hypothesis is always going to be equality. Alternative could be less than, greater than, or not equal. You actually going to figure that out from the question. Okay, I'm going to walk you through an example now. Take a look at this. The vice president in charge of sales for a large corporation claimed that salespeople are averaging no more than 15 sales contact per week. He would like to increase this figure. Okay, as a check on his claim, n equal to 36 persons are selected at random, and the number of contacts made by each is recorded for a single randomly selected week. The mean and variance of the 36 measurements were 17 and 9, respectively. Does the evidence contradict Vice President's claim? Use a test with level alpha equals 0.05. Now I need you to pay attention to this. I want us to come, the very first thing I'm going to do in hypothesis testing is to be able to specify the null and the alternative. Now, how am I going to know the null? How am I going to know the alternative? Now, I'm actually going to come to take a look at this. What is the meaning of that? It said no more down. No more down. What is the meaning of no more down? No more down is this guy. Less or equal. Does that understand? No more down. It could be that or less than that. Now, if I have less or equal, what is the opposite of less or equal? The opposite of less or equal is greater than. Okay? Now, I told you in the non-hypothesis, instead of us to write less or equal, we're always going to write equality. And that was why in the non-hypothesis, you saw that equal to 15. In the alternative, you saw greater than. Does that make sense to everyone? Does that make sense? Is there any question on that? Okay. Now, we want to see whether we should apply Z or we should apply T. We got our Z and T, but we got condition that we're actually going to see whether we can apply Z. Okay, the sample size has to be at least story. What is the sample size here? We got a sample size of 36. Okay, we're told. Then you see this guy, sample size of 36. Because of that, I'm actually going to say, uh, you know, that Y bar now will follow normal distribution. And if that happens, I'm going to show you what my formula is going to be. Okay, my formula is going to be this guy. Okay, which is going to be sample mean minus the hypothesized value divided by the standard error. And how am I going to get standard error for mean? It is the square root of sigma square over n. So what am I going to do now? I can start plugging in values. I know what my mu naught is 15. So when I start doing that, I'm actually going to have this guy here. Okay, Y bar 17. How do I know it's 17? Okay, do you see from we were told? Can you see that statement? We were told that the mean and the variance of the 36 measurement were 17 and 9 respectively. So which means the mean is 17. That sample mean, what you got from the sample, and the standard and the variance is 9. Then that was how I got all of that. Then I plug in. You see, my test statistic actually give 4. Is there any question about how I got my test statistic to be 4? Any question on that? Okay, now after getting this, what is the next thing to do? Now we're actually going to go to the rejection region because I'm dealing with a greater than. I told you, what we're dealing with is a greater than. The rejection region is actually going to be that guy. Z greater than Z alpha. Now, what am I going to do now? The Z alpha is given to be the level of significance. If you take a look at this guy, you'll be given alpha to be 0.05. Or what you're just going to do is to go to the Z table and check, for 0.05. Like I said, I'm going to attach the whatever table you need to the exam document. When you do that, okay, it's actually going to give you 1.645. The Z-score is going to be 1.645. I told you the other time, when alpha is 0.05 and you are focusing on one tail. What do I mean by one tail? One tail is either greater than or less than in the alternative. So if alpha is 0.05, Z alpha is always 1.645. Okay? It's always 1.645. Okay? And if you want to check this in the table of a Z, what you actually going to do, okay? I want to do alpha is 0.05. What I'm going to do, I'm going to subtract this from 1. So if you want to check your table, you're going to check 0.95. You check in the middle of the table. When your graph is 0.95, what values of Z will give you the 0.95? Does that make sense? Now, and what we're going to do now, we're going to compare the test statistic with the want to see whether it falls in the rejection region. And let me tell you, the rejection region for the test is that when the test statistic is greater, we should reject H naught. What is happening now? 4 is greater than 1.645. Then that was why we said we reject H naught. Rejecting H naught means you are actually going against the vice president claim, because the null hypothesis supports the vice president claim, and that was why in the conclusion I said at alpha equal to 0.05 level of significance, the evidence is sufficient to indicate that the VP's claim is incorrect. Okay, and that the average number of sales contact per week exceed 15, because when you reject the non hypothesis, when you reject this guy, your conclusion will be in favor of the alternative. Is there any question on that? Is there any, go ahead. That's a very good question. We got two ways to take a decision in hypothesis testing. One is to use rejection region. Another one is to compute p-value. You're very, very correct. Now, you know what I'm going to do now? Send me a message for that, for extra credits for that. Now, do you know that if I don't want to, if I don't want to use this guy, if I'm not interested in rejection region, now if I have Z to be that, or if I need to get a p-value, which is going to be probability of Z, okay? Now to know the sign, I'm going to go to the alternative. Alternative is greater than, right? Greater than 4, okay? And this is going to be the same as 1 minus P or Z less or equal to 4, because what you're going to check from the table. Now, if you want to check this one, you're going to check when Z equal to 4, what is the corresponding probability? Does that make sense? That corresponding probability now, you're going to subtract from 1. I know when you check for Z less or equal to 4 in the table, it's going to be 0.999 something. By the time you subtract from 1, it's going to be so small. And what did I tell you? When a P, you're now in that case, you're now going to compare your P value with the alpha. And do you know when to reject? When P value is less than alpha, you reject. When P value is greater than alpha, you fail to reject. So that's another way to take a decision. We can make use of a rejection region. We can make use of a P value. Does that make sense? Okay. Now, okay. It doesn't matter. It doesn't matter. But most of the time, like what is common in the scientific or research world is the use of P value, because that one can confuse people, but they know that, oh, I just need to get my p-value, and when my p-value is less, I'm going to reject. That is binding anywhere in the world, irrespective of the test. It's always going to be true. Does that make sense? Okay, now, you know what we finished now? We just finished a large sample where we got at least 30, and that enables us to use a Z, but we can also have a small sample. Okay, we got a small sample. We're no longer going to use Z. It's going to be T, but the formula remains the same, except that we're using sample standard deviation instead of population standard deviation. And this is the rejection region. Okay, if you want to use rejection region, and we're going to be checking from T table, and there's going to be n-1 degree of freedom. Okay, you know, we did something similar to this in our confidence interval. Okay, we're also doing it here now. Now let's take a look at this example. Assuming that the muzzle velocity are approximately normally distributed, we can use the test just outlined. We want to test this hypothesis. You know, in this question now, they've already given you what you are testing. You're testing that against that. This is an example of a lower tails. Lower tail test, because the non-hypothesis is less than. When you have a greater than, that's an upper tail test. Upper tail tails. You know, upper tail tails and the lower tail tails, we call them one tail tails. Does that make sense? Okay, now, if we're giving the mean, you know, we're giving the, like here now, they give us, if the sample mean is this, is the standard deviation is this, and we have a sample size of 8. Sample size of 8 is less than 30. That we're not going to use Z, we're going to use T. You see that now? It's still the same. But the only thing that we need to do is how we check our table. You remember in chapter 8, okay, that we did sampling with T. Now that is going to guide us in checking the table. If I want to check the table here now, take a look at this guy. Why am I checking T less than, why am I checking T less than negative 0.025? I'm actually going to tell you the reason why I'm doing that. I'm going to go back, take a look at this. When we're talking about less than, rejection region is going to be that. When you were talking about less than, rejection region will be that. It's going to have a negative. Whatever you check from the table, you're actually going to put a negative on that. We always do that when we are testing less than and when we're dealing with a small sample. Take a look at that. Okay, now, and if I want to check from table, okay, because I have 8, I need degree of freedom. Okay, and here they gave you alpha to be 0.025. I'm going to check the T table at 0.025 and at degree of freedom 7. That will give me 2.365. And then you are not going to see negative from the table. You are going to be the one that will put the negative on that because of the fact that the alternative is a lower tail. Okay, now what is going to happen? I need to pay attention now. We got this guy. When we calculate, we got this guy. When we check from table and look at the law, I'm going to show you the law right now. You see what the law is saying? Reject H naught when T is less than what you check from table. Now let us see now. Okay, is this guy less than that? Yes. This is the most negative. This is less than that. Okay, and because of that, we said the null hypothesis is rejected. And when the null hypothesis is rejected, you're actually going to conclude in favor of the alternative. Where's the alternative? You're trying to say, oh, that means whatever will be less than 3,000. Okay, so now I go ahead. Uh, you want to, can you repeat that question? Oh, we're assuming they are giving. Of course, they are always going to be giving because it's just like I've investigated. I have a sample. When I have a sample, I will always have the mean and the standard deviation. So I'm assuming you've been given the mean to be that. Okay, even though this is a claim, 3,000 is a claim. You know, whenever there's a claim, investigation follows a claim. And in investigation, you take a sample, then you're going to get some basic statistics from the sample, which is going to include the mean and the standard deviation. Okay, now I want to move to the next one now. Now we are done with one population for mean, considering large and small sample. Is there any question before I move to two populations? Is there any question? Okay, I want to welcome you to two population now. Okay, two sample hypothesis test of means. Now let me tell you this. You remember when we were working on confidence interval? We consider two population as well, and there are different kind of scenarios. There are situations where the population standard deviation are unknown, right? And there are situations where they are known, and when they are when they are unknown, they can assume to be equal, right? And they can also assume not to be equal. We use the idea of a pool variance and stuff like that. We're also going to have it under the hypothesis testing involving the means. Now, the first scenario, I'm working with the independent samples and the two population standard deviation are known. You remember when we're constructing confidence interval for that, we use in our formula, we got a Z, right? Okay, now take a look at this guy now. Okay, so situation where we want to conduct hypothesis testing involving two populations. This is going, let me first show you the formula, the test statistic. Give me 1 second. This is the test statistic. Okay, when the two population standard deviation known, and I'm dealing with two population. Okay, the first one, y bar 1, sample mean from the first group, sample mean from the second group. The D0 is actually going to be assumed to be 0 because under the null hypothesis, what are we testing? Under the null hypothesis, we're actually testing there is no difference. So it's always going to be, the null hypothesis is always going to be a difference between mu1 and mu2 is 0. The null hypothesis is saying there is no significant difference. But the alternative could be any of these three. It could be that the mean of the first population is less than the second, or the mean of the first is greater than the second, or we can say they are not the same. Does that make sense? Okay, now since you have seen that, then I will quickly walk you through an example for two populations. I need you to be focused. A psychological study was conducted to compare the reaction times of men and women to a stimulus. Okay, we got two categories now. They want to compare their reaction time. Independent random sample of 50 men and 50 women were employed in the experiment, and we have these results. And they want you to, they say, please pay attention to this. Pay attention to this. What is this? He said, do the data present sufficient evidence to suggest a difference? Whenever you see a difference, that's the alternative is going to be not equal to. Does that make sense? Here they did not say we're not testing for greater than, we're not testing for less than. Does that make sense? Okay, now, and they wanted to use alpha to be 0.05, and they gave you this data. You got this data. They selected 50 men randomly, 50 women randomly, and from the 50 men and women, they got the mean and they got the sample variances. Is there any question on that? Of course, they're always going to give you that. Okay, now, if you want to solve this problem right now, you need to first start by looking at the question and specify your null and the alternative hypothesis. The null hypothesis is going to be mu1 minus mu2 equal to 0. You know what that means? There is no significant difference between, the way men and women, between the reaction times of men and women to stimulus. While the alternative is saying there is a significant difference. Okay, after you're done with that, then the next thing is to see whether we should use a formula that we have to do with t-test or z-test. But if I want to know whether I'm going to go for z-test, I have to look at the sample size taken from each population. If the sample size is at least 30, I will go for z. Okay, now the sample size is at least 30 because they choose 50-50. Okay, now because of that, I'm actually going to use z. Okay, you see that? I'm going to use z. Okay, now you can use the idea of p-value. You can use the idea of rejection region. The rejection region for that situation is going to be this. Now I need to pay attention. Whenever we are dealing with a two-tail, right? The rejection region is going to be absolute value of z greater. Absolute values of z greater. Okay, now I'm going to show you something now. Take a look at this. I've now plugged in the values. The first mean, the second mean, all of these you've been given in the table here. You've been given in the table here, right? All of that. You just plug their mean. Okay, when you plug their mean, what do you get? You get negative 2.5. Okay, you get negative 2.5. Okay, now I'm going to walk you through using rejection region and using p-value. Now, using rejection region, Okay, because I'm working with is alpha to be 0.05. Okay, alpha to be 0.05. I'm actually going to consider Z alpha over 2 because of the fact that alternative is a two-tail. Okay, and when alpha is 0.05, the Z score will be 1.96 when you check from the table. Okay, because we're talking about two-tail. Now, if you take a look at this is 1.96 that we check from the table. Then this is a negative for two-tail. You take the absolute value. Look at that. Absolute value converts negative to positive. Now, there's going to be positive 2.5. What happened? Compare this with this. What happened? That is greater than that. When that is greater, what are you going to do? You reject H naught. Rejecting H naught, you know what that means? And that was why I said here, rejecting H naught, I said, you know, when I'm rejecting, I have to state my level of significance because I could take a different decision when I consider a different level of significance. Look at the way we normally say at alpha equal to 0.05 level of significance, we got a sufficient evidence, okay, that permit us to conclude that the mean reaction time differs for men and women. So what are we accepting now? We're rejecting, give me 1 second. We're actually rejecting this guy, and we're going to make a conclusion. When you reject the null, your conclusion will be on the alternative. Does that make sense to you now? Now, if I want to use p-value, please, I need you to pay attention. If I want to use p-value here, if I want to use p-value, okay, the way we calculate p-value for two-tail is different. Now, it's going to be 2. You're going to do 2 multiply by probability of Z, probability of Z greater than Z absolute value. You know what I'm going to say? You convert this one to positive. I'm sorry, positive. No, it's negative here, right? Now you need to find what is the probability of Z greater than 2.5. What are you going to check from the table? So this is going to be the same as, I want 2 times probability of Z greater than absolute value like of this. Now, in this case, now 2 times Z greater than absolute value of that 2.5. Now, 2 times, now there's no greater than in the table. I'm going to do 1 minus the probability of Z less or equal to 2.5. So whatever that I got, when I check from table, I subtract from 1, then I multiply the final answer by 2. That because it is two tails. Because the alternative is not equal. Does that make sense to you now? What if I want to ask in a multiple choice, and maybe I was talking about greater than, alternative is greater than, and I got a p-value, and I say, okay, if that question, so if I want to treat that question as not equal, what am I going to do to the p-value? This is it. If this represent the p-value of a greater than, like when the alternative is greater than, maybe they give you a particular p-value, and they say, okay, if I'm no longer interested in greater than, and everything stay the same, and how can we get the p-value for two tail for the same question? What am I going to do? Multiply it by 2. Does that make sense? Okay. Now, wherever I stop today is where the question, the exam is going to stop. Does that make sense? I promise you that. Okay. The one we just considered situations whereby we want to compare means in two populations, and you know what? The population standard deviation known. What about situation where it is unknown? Okay. Now say unknown, and we assume them to be equal. Oh, if they are unknown and they are assumed to be equal. You remember when we're dealing with the confidence interval, we apply pool variance, right? We're also going to apply pool variance in the test. Does that make sense? Now take a look at that. You have this question now, right? They gave you sample size that, and they gave you that, but they did not give you variance. But you can use this to find variance. Don't forget that summation y minus y bar all squared divided by what? N minus 1. That would be variance, right? And this is your n. Does that make sense? Now, take a look at this question now. Example, give data on the length of time required to complete an assembly procedure using each of two different training methods. The sample data are as shown. Is there sufficient evidence to indicate a difference? Look at that again, a difference. That would be two tails. Does that make sense? Now, I need you to pay attention. There's going to be a slight change in the formula. I'm going to go back to the other formula we used the other time when the two populations and deviation are known. Please look at that. Let me do this so that I don't. Can you see this? When the two standard deviations are given, okay? When the two population standard deviation are given, we normally use this guy. Does that make sense? But even if the two population standard deviation are not given, if the sample size is large, we can still use this guy. Does that make sense? I'm going to say that again. Okay, when the two population standard deviation are given, there's a difference between population standard deviation and sample standard deviation. They are not the same. What I'm trying to say, we're going to use this formula here when the two population standard deviation or two population variances are given. And even if they are not given, but the sample size is large, and how large is large, at least story, we can use this. But I want to show you another one. Now, take a look at this formula now. This is different. What do you see? SP. That very SP is the square root of a pool variance. We normally use this when the two population standard deviation are not given and they are assumed to be equal and the sample size is small. How small is small? It should be less than 30. That is when we use that. You remember the way we normally find our SP squared first? You need to find SP squared that we call pool variance. That we did when we're constructing confidence interval, we did the same. That is going to be, I'm actually going to write that because of my time. Okay, you remember it's the same. It's going to be SP squared, N1 minus 1, S1 squared, N2 minus 1, S2 squared, divided by N1 plus N2 minus 2. You remember? That is the formula. Okay, this and that are sample I need 4 things here. I need a sample size from group 1, sample size from group 2, sample variance from group 1, sample variance from group 2. Okay, we've already applied that. And before of us we got that SP squared. Okay, after getting that, we find the square root to get SP. Then we're going to use the SP in the formula there. Okay, so by the time you now use that, okay, finally, you're actually going to make use of the formula. It's going to be T, and that will give us 1.65. Okay, now some of you may be wondering, how do we get 195, 195.56, N1 minus 1 times the sample variance? Now, how are you going to get a sample variance? This guy divided by N1 minus 1. To get this guy, because these are not sample variance, because the sample variance, okay, x squared is summation y minus y bar squared over n minus 1. Does that make sense? Okay, now that's what you're giving. Okay, now when you have a T calculator now, then using rejection region, when you are dealing with T, you can be using rejection region. When you are dealing with Z, it will be very easy using p-value. Okay, now I got T to be that. What is the condition to reject? Okay, condition to reject remain the same. C has to be greater than absolute value of T. Okay, that's a condition to reject. Okay, now this the 1.65 is that, then I need to go to the T table. Oh, if I want to go to the T table, I need degree of freedom. What is the degree of freedom when the population standard deviations are not given and we use a pool variance? Of course, the degree of freedom is N1. You remember I told you N1 plus N2 minus 2. So that would be the degree of freedom, which is what I'm finding here. Do you see that? 9 plus 9 minus 2. The degree of freedom is 16. I'm actually going to check 16. What was the alpha given? Alpha is 0.05. Because the alternative is 2 tail, I will divide alpha by 2. And that would be what? Did you see this guy? 0.025. Because alpha is 0.05. Because I'm working with the 2 tail, I will divide it by 2. Then I will check 0.025 under the degree of freedom 16 in the T table. And that will actually give me 2.120. What am I going to do now? I will compare this with that. What is happening? This is less than that. And the condition to reject is when it is what? It is greater. Because it is less, then we're going to fail to reject. And that was why I said this value does not fall in the rejection region, because it is less than what we check from the table. And of course, we're going to say there is insufficient evidence to indicate a difference in the mean. And that's how that is done. Finally, today, I want to walk you through hypothesis or possible errors in hypothesis testing. Let me tell you this. Nature always know the truth. Let's say the null hypothesis is true. But this is, what you have here is an action that we take. What you see here is the state of nature. States. Because nature always know the truth. Does that make sense? Okay, state of nature. What we normally want to do is to speak the mind of the nature. Now, let me tell you this. There are two possible errors in a hypothesis. The first one is called type 1. Type 1 means the non-hypothesis is true when the non-hypothesis is true, but what do? We reject that. That's a type 1 error. The type 2 error, when the non-hypothesis, what is true is the alternative. But what do? We do not reject H0. Okay? And H0 is not true. That's what we call type 2 error. We can rule out that in research. And what is correct? This is correct is okay. When H0 is true, we do not reject it. And when HA is true, we do not reject. We reject HO. That's a correct decision. Okay, and correct decision is what we call power of a test. Power of a test. Power of a test is the ability to take correct decision. Rejecting the non-hypothesis when it is false and accepting it when it is true. Does that make sense? I will quickly give you a scenario under this. Let's say the non-hypothesis is the day is going to be dry. Of course, alternative is going to be the day is not going to be dry. There's going to be snow. Does that make sense? I'm just assuming now. If they give you the non-hypothesis, you should be able to, the complement of the null. When you go against the null, you can write the alternative. Now, let's say this is a school now, right? And the non-hypothesis is the day is going to be dry, and the alternative is there's going to be snow. Now, I can ask you to explain in that scenario what is type 1 error. You know, type 1 error is rejecting the null hypothesis when it is true, right? It means in that situation, when the day is you know, if it is true that the day is going to be dry, and we took a decision that there's going to be snow, the university can tell the student to stay at home, right? Don't come to school. And if they don't come to school, they can ask them to do remote. We've done it before, meeting remotely, right? That is type 1 error. Now, type 2 error is when the null hypothesis is false, but we fail to reject it, which means we took a decision that the day is going to be dry, right? And eventually, you know, what happened? Snow, okay? That, you know, this the it means the student will come to school, right? That would be type 2 error. Can somebody tell me which of those two error is worse in that scenario? Type 2, because the danger of the road. You see children, you know, parent driving or bus driving in a bad weather. Okay, I'm going to give you another scenario. In the court of law, the null hypothesis is an accused person is presumed to be innocent. It's H naught. Alternative is guilty. Okay, now I can ask you, oh my God, you know, I'm already reviewing my final question. Now I can ask you, in this scenario, which one is type 1 error? The type 1 error is when the null hypothesis is true. True means the person did not commit the offense, but is being found guilty, which means he's going to go to jail. That is type 1 error. Type 2 error is the null hypothesis is false, okay, but they fail to reject it, okay, which means the fact that the man claim is guilty is not guilty, but they discharge him and acquitted, which means and that you know, is going to be set free. And that is why I normally say criminals at times live around us. But if you take a look at that, the law will still catch up with him later. Now, in this scenario now, out of type 1 and type 2, which one is the worst? Type 1, which means it is not all the time. You know, if I want to know which one is worse, it depends on the scenarios, because I want to believe any reasonable criminal justice system will not want to send an innocent person to jail. Even though they made a mistake, releasing somebody who committed the criminal, it cannot hide forever. I think I'm going to stop here. I stop at the possible errors. The other one is just explanation of that. Okay. Okay. I want to appreciate every one of you for, you know, attending my lecture this semester. You guys have been kind of wonderful. We're not meeting here on Monday. It's actually going to be remote. By Sunday night, I want to see the list. If you are going to be in a group, like I said, maximum of 3 people in a group, including you, okay, you write the name of the person in your group, send it to me. And if you want to work alone, send a message to me. I'm working alone. For those who work in group, right, it is only one person the group will nominate, even though they work together, but the group will only nominate one person to present on behalf of the group. And whatever the person get, then the other members of the group automatically get the score. Does that make sense? Okay, Monday, we're not meeting here. Like I said, Monday, we're not meeting here. What is the last day of lecture? Today is the last day of lecture. Are you sure? Yeah, I think it's Monday. Oh, okay. You know, that was why I put the presentation to be the last day, which is so. And another thing you should be expecting tonight, I'm going to put a final practice question, and then I'm going to make a video. Please watch the video. I will share the link, just like the way I did the other time, to explain the video. Like I said, you guys have been wonderful. Go to the exam, blast the exam. Don't go to the exam with a difficult mind. Believe you're actually going to succeed. Okay. I wish you best of luck. Okay. Bye for now, everyone.